is Leah Schoeb, and I'm from AMD, and I am what they call a developer relations manager. And so basically what I do is I make sure that all of our storage vendors are working, well, our storage partners, most people's vendors, are working well with AMD processors. So I spend a lot of time not only on the technological side and the futures, but I also spend some time in validation and making sure that current products are working well with our processors. And so that's how I got into looking at qualification and how do we accelerate that process between the processor company, the OEM or ODM, the customer. There's a whole ecosystem that goes on in making sure that our drives perform the best. Most of the time I run into folks that aren't in storage, and the first thing I hear is, oh, you don't have to worry about that, storage just works. And I have to laugh. I got that from our legal department a couple of weeks ago when we were having a conversation. We're like, oh yeah, we don't have to have that conversation, it just works. And I'm like, there's a reason why it just works. So I'm going to talk about that today. We'll talk about why to qualify, why do we care? And also the types of drives. We have now segmented with the market, and based on use cases, we now have different types of SSDs and solid state technologies that we use based on the use case. So that also complicates things. And talk about what to qualify. So you have a particular type of drive, what do we do? What do we measure? What do we look for? And so it's a pretty interesting, elaborate process. One thing that I didn't put in here, and one day maybe I will put in the slides, are the processor vendors. Your AMD, your Intels. We're stuck somewhere in the middle right here. And a lot of times, folks like me end up having to broker a lot of that communication between the drive manufacturer and the platform supplier. And so that's basically the bane of my existence when I have to do that. But we've got controllers and firmware and unique features, and all of that has to work well with what's going on with the processor and chipset and what the BIOS can see. And so what we have found is that, that we may make changes in our BIOS that may cause problems with a drive manufacturer's firmware. And so now we find that there's incompatibilities in our firmware and our BIOS. So spending a lot of time going back and forth with our architects, making sure that we are designing together is one of the big goals that I have. So now I'm having conversations with a lot of the drive vendors about what's happening in 2024. What are your plans? What does your roadmap look like? Here's ours. Well, what kind of design decisions are we making? Are we still going to use this protocol? Are we going to phase this protocol out and use a new one? And we need a different form factor. And those conversations have to happen so that by the time the drive and the new processor is developed, things are a lot more seamless. So I'm spending a lot of time working in that area. But for current products, we also end up getting the customer involved as well. And because we see their feedback, we see their complaints, there's a lot of things that happen in the OS that may cause us to have to spend some special time in, like modern standby, for example, for power management. That's a big area that we need to spend a lot of time in. And a lot of people don't realize that when they open that laptop and it just turns on, all the components and everything that happens to make that happen and to allow your drive to actually communicate, there's a lot involved. So this process is huge. It's a big deal in order for disk drives to just work. And don't get me started on USB. USB is like, yeah, that's a whole nother story. So today, not counting persistent memory, NVDIMMs, those types of things, not even counting what we do for those. Just what we do for solid state devices alone, we've got four actually main categories. We have our data center and enterprise, which is what we see in most data centers today. This is mainly for service providers. That's mainly for enterprise platforms that we see. And then we have the client side, and we've got 2 drives for that. We've got client level drives and we have consumer drives. And yeah, they both have the same types of features. But the quality of those drives can be different. So you'll find that your client drives, like, for example, your HP specific drives that they have qualified into their HP systems, the performance behavior, the stability, the reliability is going to be different than what you see in consumer. Consumer, in certain areas, you're going to see more performance instability some cases because of how they did their caching algorithms. Their caching algorithms can be simpler than what you see in a client drive. In a client drive, they try to make things a lot smoother, kind of mimic what you'd see in the enterprise. So you'll see a difference in those drives versus what you get from the channel versus what you actually purchase as a client drive. Data center drives. This is an interesting area that got invented because service providers were buying client drives. And the reason why they were doing that was for cost. And they didn't really care much about all the features that you have in an enterprise system. You think they got a data center? You think that they would want to purchase enterprise class drives. Well, because of the volume of drives that they purchase, they find that they can save a ton of money if they get client drives. Well, the problem with using client drives in an enterprise system is it doesn't have the level of reliability, the power loss protection, a lot of these features that you see here. Some of these have to be data center grade. So therefore, drive vendors have come up with a new version. They've come up with something that is lower cost than an enterprise drive, but gives them the protection that they need. And so this was kind of a happy medium for them in order to do that. Well, when you validate these drives, each one has their own characteristics. For example, if you're looking at a data center or enterprise drive, once it's turned on, it's on. It's rare that you're going to turn off a data center or an enterprise level drive. So power management isn't exactly top of the list. There's a few things you might test for, but all in all, once you turn it on, it's on. But when you deal with client and consumer drives, power management is one of the most important things on the list. And the level of idle, the level of active, there's standards around that. And so that's where you end up spending more of your time outside of performance. You'll be spending a lot of that time in power management and making sure that it deals well in mobile products, laptops, gaming systems. It's actually, I'd say, a bit more challenging than the enterprise drives. I come from the enterprise side. So when I came to the client side, I was surprised at the complexity of a client drive. And in a lot of ways, it's a lot more complex than what you'd find for the data center. There's 4 main areas that we look at when we try to qualify drives. Of course, we have to look at reliability, make sure that it's durable, performance. Everybody sees that performance. Power efficiency. We have an increase now in power requirements from Energy Star and also states like California in the US. They are becoming stricter and stricter about power requirements and lowering power standards. So that's something that we have to pay a lot of attention to. And especially on the client side, you spend a lot of time looking at how can I spend my power budget and how can I extend time in my laptop, for instance. You know, power life, you hold it up, you don't want just 8 hours, you want 10 hours. And so what do we do to shave power off so that we're able to extend battery life? So there's a lot of effort that goes into battery life. Anytime you have your Mac open and it works for you all day long, be grateful. Because a lot of engineers, there are hundreds, maybe thousands of engineers that go into just power efficiency alone to make sure that you have that convenience. Functionality and compatibility is another big area because there are unique functions that the processor vendors actually create that the drive vendors need to take advantage of. One is about battery life. There are other things, so we need to make sure that all the function and compatibility is actually working. For reliability, a lot of it is around actually getting the system up. Does it boot? And does it boot again and again and again? And you may run a test where it will cold boot that system 1,500 times just to make sure that it does not fail once. And if you're booting 1,500 times and it fails on 996 round of that cycle, guess what? You're going to stop, you're going to open a ticket, and you're going to find out why. Because we don't need anybody opening up their laptop and it not work one day because of that 996 time. So there's a lot that goes on in making sure that things are reliable. There's standards that you follow to make sure that your configuration and your power interface is standard across the board so that all of the OEMs and ODMs that are making mobile products and desktops especially follow these standards. Modern standby, for example, is something where that brings in a feature from the OS. So the feature is not coming from the processor vendor, and it's not coming from the platform vendor, and it's not coming from the drive vendor. Well, where is it coming from? It's coming from Microsoft. And this is a very important power management feature. And understanding exit latency is very important because that user experience is very important. This is just a cross example of benchmarks that are used for looking at performance. So if you're looking at a client drive, you may use a I/O generator like Iometer, and you may use a benchmark like Crystal Diskmark to measure 1 to 4 drives. And that's good enough for desktop platforms, for mobile platforms. In fact, this was built at Intel and designed at Intel for that purpose. If you're in the data center or enterprise, you may want to use something a little more complex like a VD bench. There's a few others out there that are more enterprise-like that allow you to be able to recreate real enterprise workloads and data center workloads so that you're able to do some workload testing on top of the regular speeds and feeds that you do. Power management, as I've mentioned before, is extremely important, and usually you find this more in client and consumer drives. Your idle states, there's all of these are part of standards. There are standards bodies that have decided what the idle states are going to look like, what our sleep statements are going to look like. If you're looking at, for example, let's say L1 substates because you would like to save more battery life. That's something that is very important to enable and have a feature for. So that maybe, like today with Intel, with AMD, we look at L1.2 substates because it gives us up to an advantage of 45 minutes to an hour more battery life to all the products that you work on. So these things are very important to test and to go through and make sure that each one of these steps works, because you want to make sure that your phones, your tablets, your workstations, your gaming systems, your consoles, everything just works. Functionality and compatibility is extremely important. Any change that we make in the BIOS can break a number of things. And not just storage. We're looking at all kinds of peripherals. We're looking at cameras and sensors and everything else. So anytime you make changes in the BIOS, you have to work closely with storage companies to ensure that their drive firmware is compatible with BIOS. Another thing is partitioning. Just basic testing to make sure that drives can do the basic partitioning, maybe do some dynamic partitioning, and even looking at PCIe. With us, you know, we have our Gen 4 platforms, and what we find is that following the PCIe spec can be challenging, and interpreting the PCIe spec can be challenging. So there may be a situation where there's a range in the PCIe spec that says, hey, anywhere between 0 and 33 milliseconds is fine for this signal. And so one engineer will look at it and say, okay, they said 0, so I'll just put in 0. Well, you may have drive manufacturers that say nobody's going to put in 0, so I'm going to make sure and delay that a little bit, and I'll put in 5 seconds or 10 seconds or 20 seconds. And what you'll find is then the signals don't connect, they mismatch. So as the system is waking up, it's waking up too soon. Or the drive may not pick up the signal because it woke up and then went to sleep before the drive could even see the signal. So a lot of signal integrity validation needs to be done. And backwards compatibility to former generations like Gen 3, Gen 2, Gen 1, all of these have to happen, because especially if you're doing some dynamic work with PCIe implementations, depending on the state of your server or of your desktop platform, you may be going back and forth between different generations of the PCIe spec. And a lot of people don't realize that. They think, well, once you're in Gen 4, you're in Gen 4 all the time, and that's not necessarily true. There are backwards compatibility features that you need in some of the other PCIe specs, so you may bounce back and forth. All of that needs to be validated. And we have found that there are issues if there's not a tight communication between the processor vendor and the storage vendor. And overall compatibility under stress. And this is very important for servers and for mobile and desktop products. And so these are some of the areas that you have to look at. You have to look at workload behavior. And if you don't have the appropriate level drive in the appropriate level system, you'll find some strange behaviors with your workload. So if you have a data center type of workload in a service provider, but you decide to use the client drive, and you expect that same consistent level of performance with a data center level type of workload, you're going to get some strange activities. A good example is, I don't know how many of you have spoken with Netflix or seen them present at events. They've also presented at SDC in the US. And when I had conversations with them, one thing that I found was that they were using client drives for a data center workload. And so they were wondering why they weren't getting the reliability that they needed. Why weren't they getting the throughput that they needed? And so there needed to be a little bit of education that a drive is not a drive is not a drive. You have to be very careful which drive you choose, just like you're careful of what processor you use. You wouldn't take a mainstream laptop processor and put it in a server. So why would you do that with storage? So there's a lot of education that needs to be done around that outside of just actually running the tests. You want to look above what's happening with the processor and storage firmware. You want to make sure that it can handle file systems. You want to make sure that it can handle RAID. There's a lot of issues and performance issues that you can see if you don't validate what happens under RAID 0 with striping or RAID 5. You can find some pretty strange behaviors. We've found some strange behaviors between using a consumer drive versus using a client drive. So we have found that consumer drives actually, because of how they do their caching algorithms, can cause strange effects during high performance peaks. Normally they perform very well, with a single drive, but as soon as you put 4 drives in a system and you use RAID 10 or you use RAID 5, you start seeing irregularities in your performance. And so these are things that need to be figured out. Sometimes there needs to be either a redesign or the fact that you're not using the right drive in the right system. So that's something that's very important. So in summary, codec validation is very important. It's very important between the processor company and the storage company and the OEM and even the OS companies. All of them have to work together just to make sure that storage works. Make sure that the right drive is in the right system, because that has caused a lot of problems and a lot of heartache at a lot of end user customer sites, because they think a drive is a drive is a drive, and I can just go on Amazon and buy 100 of these, or call a drive company and buy them direct by the thousands, not realizing that they're not buying the right drive for the right system. So that's something that's very important. Comparing drives. Make sure that when you do have 2 comparable drives that you are comparing, make sure that the configurations are the same, make sure that the methodology is the same, make sure that there's an apples to apples comparison when you are validating, when you are doing that benchmark, because sometimes you'll find a drive that performs great, and so you want to benchmark that against another drive that you think might have some performance issues. Well, you can't cut corners in an apples to apples configuration. If you cut corners, there's no way of actually pinpointing and identifying the problem. So it's really important to make sure that qualification happens in all 4 of these areas for each type of drive. All right, well, thank you.